Hello everybody, welcome back to the channel. This is Michael, KE4EST. And if you remember, I think it was back in November actually, I shot a video about going over this unit here. This is the HP 711A, 711 Alpha. You know, maybe doing a restore on it or whatever and just going over it. So I have done that for the most part. Still need some outside cosmetic stuff done if I decide to do it, because I may set this up and use it. You know, it's not going to be a shelf clean up there just to look at, you know, whatever in the museum. Still got stickers stuck on here and things like that. Well, there's another sticker there, but I have restored this. But first I'll go over it a little bit more. I think I kind of went a little fast over it the last time, and just a refresher. The first thing I'm going to say is, right up in front of the video, if you decide to tackle something like this, this is a high voltage supply that goes up to 500 volts output here. There is more than 500 volts on the inside of this thing. You know, make sure you know what you're doing. You're familiar with vacuum tube equipment, vacuum tube things. You've done this, handled it, feel comfortable with doing it. As if you don't feel comfortable with it, you kind of, I don't know, but I kind of like to, don't do it. You know, get somebody to help you or whatever, but don't. Doesn't mean that you can get hurt really bad or even killed with this, you know, messing with this stuff. I mean, same, you know, with any tube stuff, but this has got a lot of voltages in it, so that's just you know, for the sake of yourself, just don't do it. Just watch me do it. But anyway, you know, there's plenty of people out there you can get to help you or whatever, but if you decide to do it anyway, you are doing so at your own risk. Okay, this is a unit that came out in the early 60s. I think actually, let's see, I got the schematic here. It might have been late 50s. No, the schematic says 1954. So I know they made this up through the 60s. They made this and sold this unit. From research I've been doing online and looking at things and this, that, and the other, but so I was gonna say late 50s, but early 50 or mid 50s. At least that's when the schematic was drawn, 1954. All right, so just to recap, this is a HP 711A. This is continuously variable from 0 to 500 volts, and it's got a fine adjustment. 0 to 500 volts, and you got two 6.3 volt outputs here. It's 3 amps a piece, and these have got their own windings on the transformer. This has got its own winding, and this has got its own separate winding, completely separate. So, and you know, you could have these set, and these will be there as long as the power's on. I don't have it plugged in right now. As long as the power's on, these will have power to them, so you can, you know, light up tubes or let tubes warm up or whatever, things like that, without having your high voltage on over here. And you know, you could even tie these two terminals here together. Just put a shorting bar in there, short these two here, and come out this side and this side, and you'll have 12.6 volt center tapped. You know, you could do it that way too, if you so chose to. But that's 3 amps a piece, or you could parallel them up and get 6 amps, or, you know, to less, you know, if you want to try to do 12.6 volts for your filaments. And it's got a now this will do 500 volts at 100 milliamps maximum, and actually it goes 100 milliamps on the meter here, but you got 2 meters. One's 0 to 500 volts, and if you're down below 50 volts and you want to get more of a closer idea, you can push and hold this in right here, and we'll show you in a minute. I'll go over that, but you can push and hold that, and then this will be 0 to 50 volts, so it'll be like 10, 20, 30. And same with this milliamp meter here goes from 0 to 100 milliamps. If you press and hold that, that whole scale is 10 milliamps. So if you really want something that's just low current and you're wanting to, you know, zero in, because if you look in, I don't know how good you can see it there. If you look here, real glass too. I like how it's real glass. If you look right here, if you left it without pushing this in, there's 0 to 10 milliamps right there. That's all you get. So if you're trying to look to see exactly what, you know, when you push this in and say, oh, okay, so it is drawing about 45 milliamps or whatever, instead of guessing at it. You got an on indicator here for the main power on. This is showing if you got your, you know, if this is lit up, you got DC voltage here, you know, and it may be low if these are turned down, but, and this will go, you know, you could set this up, say 200 volts, and then you can really adjust this into, you need 201, 211, 200, you know, real fine tune. Instead of trying to fine tune it with this, you can fine tune it with that there. So that's pretty much, I mean, the front and what it is, you know, 500 volts, 100 milliamps. And you got your plus and minus here and a ground. So let me, squeaky chair, let me bring this around so that you can see. You pretty much seen it in the, I'll link it in, of course, the down there, down below. You can link in if you didn't see the first video, but I will show you. So I mean, I ain't going to go through every little detail again, but I'll show you what I've got going on here, what I've done. Let me just lay this like that and bring you in a little bit closer. Like that. Maybe that'll work. So these cans, of course, they was up here. You know, I've got you too far in. These 3 paper cans, well, they're not paper cans. I'll remind you again, these are just little pretties that was over them. But these here's been replaced with these 4 capacitors here, because a lot of them was just 1 capacitor in each can. This one here was a multi. It had 4. And then this capacitor here, this big tall one right here, let me bring it so you can, this thing's heavy. Well, let me see. This big tall one right here, that's a big old tall thing. You know, and all it is a, I think it was a 4 microfarad. And I replaced it with this here, because that's what I had to, you know, do that with, instead of like the yellow ones I like to use. I went through all these resistors. Anyway, so there's that. I mean, it's, this video won't have to be really super long. I mean, I went through that. I cleaned pots up. You see these 2 pots in here? These are just your 0 sets. So, find it on the schematic here. It's these 2 here. One's for your fine adjustment and one's for your coarse adjustment on the front. When you turn your knob on the front all the way down counterclockwise, if it's, you know, trying to peg out on the negative side or not quite hitting 0 with your, if you got your coarse and fine all the way down, it still ain't quite hitting 0, you can adjust. Let's see, I think this was the coarse one. Which one was it? Coarse and fine. There's not a whole lot of alignment to do to this thing. You adjust one for the fine and one for the coarse. It's got it in the manual. Let's see, I've got, see, this is the top view I printed out, but I know 31 is fine and 33 is coarse, so it's kind of showing you that's the top, the little screws. That's, we're looking at the bottom side of those. But other than that, you know, it's mainly, it's one of these things where you're changing out the older capacitors, and I did change out the selenium rectifiers, and you remember that big mess that was in there before. Let me bring it up around. I will let you see if I can switch over to the other camera so you can see. Got this kind of in the way here, but where did my plastic pointer go? I've got a diddle stick I always like to use. Anyway, so here's the two are, and I didn't. Here's where the two go, and I just used the holes that was there, and those set in pretty good. To sit right in there, no big deal. Now remember, some of this weird looking, like you see it. Well, yeah. See that there? That wire almost looks, I got too much light on it. The camera, it's looking almost yellow, but that's orange. Where somebody went in here before and had this, there's this blue wire over here has got some on it here too. They laid their soldering iron against it. But anyway, so I went in and changed these two out. Now these, you know, you can make your own little, get some diodes. You could have got, I could have used one in 4 007s or something like that. Would have been fine. But I happen to have these. These are overkill. These are like, I don't know, what are these things, like 35 amp? These are 1,000 volt rectifiers, but you know, bridge rectifiers, and that's what it was. They had two bridges made out of selenium rectifiers, and these tall cans that stood way up, you know, almost touching this. So I got rid of those and all that mess. Well, somebody already had gotten rid of one of them, or you know, it was still in there, but it was not hooked up. They had a bunch of, you know, little, well, I think they was 4001s or 40, I think it's 4004s, weren't they? It's been a couple of months that they had made, but just floating in midair. If you remember that, if you go back to the video. So I just put those in there because I had them. They're 1,000 volts rated, and it's a bit overkill. Like I said, 35 amps, really. But you know, you can get those, and if you want to try to do the same thing, if you're going to replace them, they're not that expensive. The part number is KBPC 3510. That's Kilo Bravo Papa Charlie. KBPC 3510. If you want to, you know, try to do the same thing. But anyway, so let's go back to, let's look at the other side. Now if we go look at this side here. Alright, so now we look at the side here. Now this was something that was already from the factory. It's the only reason I didn't snip it off. It kind of bugged me, but that's the way they left it. I think this resistor here got replaced. There's some terminal tie strips in here. And there's a capacitor here. I had 4 in it. But 2 of them were in parallel. So that got replaced with those 3 capacitors there. That's why there's only 3. And here, the 3 paper capacitors that were here, the full capacitors, got replaced with these 3 here. And the only other thing I did was, I think, I'm forgetting something. It's back in here, those 2 diodes there, and I'll show you. Let's see. I'm laying right here. Back this out on the schematic. So that's these 2, and that's voltage doubler circuit. So I just went with, and I think them were the 5408s. I think is what I got a ton of those things. I think I mentioned in our videos, I've got a bunch of those. You know, and I like to, you know, go through this stuff and restore a lot of this stuff, and I have for years. So when I find something, I usually buy it in hundreds or whatever, 200s, depending on what kind of deal I'm getting. So I've got plenty in stock. But anyway, while we're at it, there's the, let's see what happens if I do this. That's too close. There's a schematic. Of course, here's those 2 separate windings here going out to those 2 in the front for 6.3 volts. You got your indicator light coming off one. Let's see, switch is there, and then you got a separate winding here for these two tubes, and you got a separate winding here for the two main regulator tubes. So let's see, we got voltage coming in here. Here's our main series tubes, or regular or pass tubes going out. And we got the control tube here, and there's a control tube over here that's controlling this tube, and this tube's controlling this tube. This one's this one's using this 5651 150 volt. Is that what it is? Let's see. So you got a reference voltage bus here. Say it says go to A. A comes up here. Coming off, this is a regulator tube. And let's see. So this is controlling, but mainly here's what's going on with this. We can go over a little detail and whatever and spend an hour, but here's your main, you got your voltage coming in. And it's coming out here and going out on your plus side here. And then tied to the grids of these 6L6s through this 560 ohm resistor and down to the plate of this half of this V4. Here's one half of the V4. It's triode, pentode combination. So, but mainly what's going on here, just to get to the gist of it, you see this here is sampling this here, the voltage. So if you got the voltage and you got this set for 100 volts and you put a load on it and that voltage drops a little bit, what's going to happen here when you drop that voltage, this here, this grid is going to go more negative than what this is coming off this cathode follower here. See how this is like a cathode follower. So this is going to go more negative than what this is, so it's going to cause this tube to kind of, not completely turn off, but turn back, cut back on the current flow, which is tied to the grids here. So as this cuts back, the grids are going to get more positive here on these main tubes. So that's going to cause these to turn on more and let more, current through, so the voltage will rise. Of course, all this happens in the blink of an eye. We're talking about it slowly here, but it happens really fast. So that's essentially what's going on here. It's a pretty good solid setup. Because see, you've got this one controlling these, but you got this over here doing pretty much the same thing, controlling this tube. So you've got really good regulation going on. Make sure that thing stays right at 100 volts, as long as you don't try to exceed the 100 milliamps or something crazy. But if it's set at 100 volts and you throw a switch, and plug in something that's pulling 50 milliamps, if this ain't here, that voltage is going to pull way down. So this is going to say, hey, I need you to turn up. It's like a little man sitting in there turning a big knob, and he's like, oh crap, I need more voltage, and he's going to turn the knob one way, and then you take the load off, he's going to go, oh crap, because you don't want this voltage to shoot past, whatever it is. It might damage the equipment hooked up to it. Whatever device you got in a test over here or whatever hooked up here may not want much more than 100 volts, and you got 100 volts on it, and well, if you take that load off, that voltage is going to spike up. This is going to, of course, all this happens, super, super fast, almost the speed of light. Not quite speed of light, but almost. It's going to turn back real quick, and it's going to drop that voltage back to, wherever you got it set at there. So that's pretty much that. All right, so let's quickly we'll turn this thing on. Things off there. Plug this in. We'll fire that up. You can see that this lit up, and that light might be just about right. I've been playing with the knob, voltage is up. Now you see that's let it warm up. I'll go from 0 to 50 volts. I do believe we need to adjust those pots in there. Well, let me see. I know it's not fully warmed up. I don't know if I want to use this screwdriver. So I gotta insulate it here, but it's kind of short. But we'll see. Oh yeah, I can get to that without causing any problems. Alright, so we're on 0, 0. Well, that ain't been turned in 50, 100 years. Probably. Wrong way. Oh, that's as far as it'll go that way. Okay, well, let's do the other one now. I don't like that not being in the center like that. Well, didn't move much, but that's the camera's at an angle, but that's pretty much 0 right there. This one over here, this, let's see, it's 32. Let's just come at it. R32 is, I don't say. R32 looks like the fine, but I'm gonna tell you wrong. Let's see. I got all kinds of paperwork here. R32, where are you? Well, let's see. Well, I was just looking at it, and I was looking at the schematic, and I'm like, this ain't making sense to what I thought I read. So I went back and looked at the manual, which is easy to find online. And that's why. R31 is for 0, and then it says take it all the way up to, yeah, see how it's going past 500. Maybe you can see that. Take it all the way up. Turn the fine and coarse controls both up to, see how it's pegging out. Then adjust the other one. That's more closer to centered, so that it's saying 500 volts. Just bring it down, bring this one down. Is that still, no. Guess that's as far as it's going to go. Okay. Alright, so now we can adjust the voltage internally. It's there, it's doing its thing, but it's not. It's got a bad glare on it. It's always the case. Stick something under that. Alright. Alright, let's go to make sure it actually is putting out like it says it is. Alright, so let's turn it on. Now we should have be live here, so let's see, we gotta be extra careful. 4 volts. Take it. Oh, see, I can go below. I have to do some more adjustment on that potentiometer in there. But anyway, this goes up. So like right there's, let's see. Make sure my hand, well, there's about 35 volts. You can barely, is it 35 volts? What is it? So you push this. Look at there, right on 35. Hope you can see that okay. Let me do this. Let me do that. So we're supposed to have 35 volts. 35 volts. You can't see the other meter, but it's saying 35.09. 35 volts. I mean, it's dead on it too right now. I know this ain't perfect, but it needs a little more adjustment, but that's dead on it. So, and then we'll just bring it on up here. Leave that off. The meter's telling me to be careful. I'm going to get hurt. So, see, there's 405 volts, and it's not quite hitting 400. So, yeah, it still needs a little bit more adjustment. And then, so you want to turn it all the way up. And I like that it goes over. I mean, I don't care that it goes past 500 volts a little bit. That's fine with me. I mean, the circuitry inside can handle it just fine. But, back this back out. So you can see we're 512 volts. All right. So, it appears to be working. It's working good. And I'm glad to get that project done. It's been sitting on the bench forever. So, there it is, the HP 711 Alpha, 711A, 500 volt power supply. So, alright, so let me know what you think in the comments. And if you got one of these or anything like this. What I don't like about this is I like that it matches other stuff, and most of the time, you know, that's what you're going to use. And a proper setup should have several power supplies than I do. I think I've got more power supplies than I do any other kind of test equipment. Well, besides voltmeters or, multimeters. But the only thing that they could have added to this, I think somehow, maybe, I mean, they might could have made this into some kind of 2 thing in the center, so the fan would be in the middle or something, and left this so they could have put an adjustment. And, you know, I think they was trying to, because it's exactly the same size if you measure it. This front's exactly the same size as the 410 B voltmeter, or the VTVM that everybody still loves today. Thinks the best VTVM ever made. The one I've got up there, it matches it perfect size. So I think they're trying to stay in there, and they made the decision, well, let's cut out the C. But I wish they had a C. You got your B plus here. Wish they'd had a C minus for the so you could set a bias, or something like that. Had a bias output. All using one supply would have been nice, but other than that, it's solid build. It's very heavy, very well done, and still doing good. So, until the next video, this is Michael, KE4EST 73.